I'm looking at the Laplace applied on a derivative. That's also on the formula sheet that I really uploaded for you in Canvas. You could download that and have it next to you on every test. That is s times the Laplace of f of t minus f of 0. And since we're going to only focus on the second, we're not going to use the general. We're going to focus on the second derivative. That's provided as well. Laplace applied on the second derivative of f is s times the Laplace applied on f prime minus f prime of 0. And it tells you what that is. And I'm giving you this part in the table. You just need to use it. And if you see a constant, you ignore a constant. This is the general formula for any power. We don't go beyond 2. So if I glance at this, in each problem 8 through 16, use Laplace Transform to solve. We know how to solve this, right? You let y equal e to the rt, and you're going to get r minus 3r plus 2. E to the 3t and e to the negative 2t will be the fundamental set. I could find the initial conditions. You can't do that. You need to follow directions. It says use Laplace Transform. How do you do that? You take the Laplace of both sides. So the Laplace on the second derivative is right there. The Laplace on the second derivative. So here it says you could do them piece by piece. Minus the Laplace applied on y prime. Minus 6 the Laplace applied on y. And the Laplace applied on 0 is 0. If I take this, this is s squared. The Laplace applied on L of f of t, that's simply capital F of s. Minus s times f of 0. F of 0 is 1. Minus f prime of 0. That's a negative 1. All of this is this. If I take this minus Laplace applied on the first derivative. Laplace applied on the first derivative. On the first derivative, it's s. So again, keep in mind, this is s times f of s minus f of 0. This is f of s. So this is going to be s times f of s minus f of 0 minus, what's f of 0? F of 0 is a 1. And this piece will be a minus 6. Laplace applied on y is simply f of s equals 0. Now all what I have to do is solve for f of s and reverse the order. And what does that mean? That means I'm looking at s squared f of s minus s plus 1 minus s f of s plus 1 minus 6 f of s equals 0. Anything with f of s I'll leave on the left hand side. If I factor an f out, I'm looking at s squared minus s minus 6 equal, and if I move those two to the right, those three, that will be an s plus 2. And now, wouldn't you say that f will equal an s plus 2 over s squared minus s minus 6, which is s plus 2 over, isn't that s plus 3 into s minus 2? And now what? Now all what I have to do is come on the side and figure out where does this come from. We learned how to do that in 5B heavily. 7.4 partial fraction decomposition. How did you do that back in the days? You do it now. So if I glance at this and I do it right, I'm writing those in case you don't remember that, but that's something you need to review. And if I let s equal 2, I'll get 4 to equal 5b. So b is 4/5. And if I let s equal -3, I'll get -1 to equal a times -5. So a is 1/5. This is 1/5, and this is 4/5. So basically, this is what I got. I got this to be 1 over 5 over s plus 3 plus 4 over 5 over s minus 2. And now guess what? If I want to find the solution to a differential equation, I'll apply the inverse Laplace transform. And don't we agree that this is simply a y of t or f of t? Let's go f of t. F of t is the solution. Isn't that f of t because that's f of s? And wouldn't that be 1/5? Isn't that e to the -3t plus 4/5 e to the 2t? And this is by what property? This is by property number 2. And how do you like that? We just solved a second order differential equation and we found the coefficients without even integrating. Well, we did integrate because we used Laplace table, but that's the same idea. Here's another problem I want to tackle. The same deal. I would apply the Laplace transform on those. I will get for number 10, I will get the Laplace of y double prime minus twice the Laplace of y prime plus twice, and I know that's f of s because the Laplace applied on y is f of s. This right here is going to give me few things. That's going to give me s squared f minus s times y of 0 is 0 minus y prime, which is a 1. Got it. This piece is going to be minus 2 times Laplace applied on y prime is simply s times f minus f of 0, that's a 0, plus twice f of s, and I lost track. F and f of s are the same, so this is going to be s squared f of s minus 2s f of s plus twice f of s equaling, that's a 0. All what I'm get on the right hand side is a 1, isn't it? Just this one. So if I take f and factor it out, wouldn't that be s squared minus 2s plus 2 equal to 1? Wouldn't you say f of s is 1 over s squared minus 2s plus 2? Wouldn't you say f of s is 1 over s squared minus 2s plus 1 minus 1 plus 2? So I add 1 and subtract 1 to complete the square. Wouldn't that be s minus 1 squared? And wouldn't that be plus 1? So to really do this, I'm going to show you a nice trick. If I want to take care of this shift, that shift will give me, this is unofficial. I'm going to write the whole thing officially in a minute. If I do that, that means now I'm looking at 1 over s squared plus 1. So this right here by 2. And if I look at, there's only one problem in the back, or one property on the right that has an s squared plus 1. S squared plus 1, that would be s squared plus 1. The top is a number, right? If the top is a number, it has to be a sine. If the top is an s, it has to be a cosine. By 5, that's going to be the sine of 1t. So now if I want to, and this is by 5. If I want to make this official, all what I have to do is say, hey, we took the Laplace and we reversed it on f of s. The Laplace allowed us to eliminate the integration, and that would be my answer. I suggest you practice writing how did you get that on the homework, because on the exam I insist on you writing that. Of course you could write e to the t sine of t. Alright, a couple more to go. If I go to problem number 12 and I apply the same thing, if I apply the Laplace on this, I will get the Laplace applied on y double prime plus twice the Laplace applied on y prime plus 5 the Laplace applied on y. If I take this first piece, that actually would be s squared times f minus s times f of 0, which is 2, minus s prime or f prime, which is a negative 1. That takes care of that. This piece, plus twice, if I take Laplace applied on y prime, that is twice s f of s minus y prime, which is a negative 1. It is y prime, right? I'm just doing that out of minus f of 0, my mistake. F of 0, what's f of 0? Minus a 2, my mistake. Yeah, I thought something was wrong. Minus a 2, right? And if I apply the Laplace on, that's simply f of s, and that equals 0. Because Laplace applied on 0 is 0. So this is s squared times f of s plus 4 times s f of s plus 5 times f of s equaling, move this to the right, that is 2s plus 1 minus 4 is minus 3 to the right, that's a plus 3 if I'm not mistaken. And if I factor an f out of those, I'll have s squared plus 4s plus 5 equaling twice s plus 3. So f of s is actually 2s plus 3 over s squared plus 4s plus 5. And I need to figure out where this came from. I could say f of s, let me see how much space I have on the bottom. Yeah, I'll take an extra step down there. I'll say f of s is actually twice s plus 3 over. Isn't that s squared plus 4s? Take half of the middle number and square it. And wouldn't you say f of s in this case would be 2s plus 3 over s plus 2 squared, that's those 3, plus 1. Now, I do have a small problem. Let me just check something really quick. It seems, let me check. There shouldn't be a 2, right? I wrote 2 twice. That would make this a 2. The problem doesn't change. You would still have to do the completing the square, except the number now will differ slightly. You would add and subtract half of 2, which is 1. And that will make it a 1 and a 4. And now, I have a small issue. The shift is very hard to get around. If you shift a constant, it doesn't change. But if you want to shift this, this is really what you must do. You must get a shift. If there's an s at the top, you want that to be s plus 1. Do you know what that means? If I work this on the side, isn't that 2s plus 2? And I can't change the problem. So what must I add to this to make it 2s plus 3? Isn't that a plus 1? If you distribute that 2 and 2s plus 2 plus 1 is s plus 3. And I will split them up because those are never together. 2 times s plus 1 over s squared, s plus 1 squared plus 4 plus 1 over s plus 1 squared plus 4. Now I'm going to start looking at the table and prep this problem to see how this is going to work. If you have the table next to you, I want to show you, and again, I'm skipping a step. If I apply e to the negative t, that takes care of that shift. That's going to make this s over s squared plus 4. There is a 2 in the front. So this is by 2. And by 2, this is going to be e to the negative t. That will take care of that shift as well. And that's going to make this 1 over s squared plus 4. If I'm looking at a plus 4, I notice the plus is only in one of those two. Again, the beauty of this section. Nothing matches except one of those. It has to be those. Now, the s over s squared plus I squared, number 6. S over s squared plus by 6. This is, what do we say, sine? Cosine. S, cosine. Cosine of at, which is 2t. Plus, here, I'm looking at s squared plus 4, and there's a number there. Here, to go from a number, s squared plus 4, they need this to be the square root of that for you to be able to go to sine. So you have to modify that slightly by saying, well, I could multiply by 2 and make that a half. This will be by 5, the sine of 2t. And now if I apply the inverse Laplace transform, the inverse Laplace transform will be f of t, which is the solution. And there's my answer. I was able to find the solution to the differential equation, including C1 and C2 by using the actual values. Now, okay, from the table provided, this is on the formula sheet. So we do a second order for the most part, but we're going to attempt to do a fourth degree, every now and then. But for the majority, we're going to be dealing with a second order differential equation, and there it is. L applied on the fourth derivative of y minus L applied on y, that's simply f of s. But L applied on the fourth derivative, look how that works. That's s to the n. So that is s to the fourth. L of f, that's f of s. Minus 1 power less for s. F of 0. F of 0 is 1. Minus, so you go with n equal 4, 3, 2, and 1, right? And none. That's always how it works. When you go to the second, that's this piece. You take times a derivative, that's a 0. And then when you go for the next one, times f double prime, that's a 1. And when you go for the third derivative, that's a 0. Minus s minus f of s. and all of that equal a 0. So this is gone, this is gone. I'm looking at s to the fourth times f minus f equaling s cubed minus s plus s. So this is s to the fourth. This is factor an f out. That is s squared, s to the fourth minus 1 equal s into s squared plus 1. And if you divide both sides by s to the fourth minus 1, that's s squared plus 1 over s squared minus 1 into s squared plus 1. Those cancel out. F would be 1 over s squared minus 1. And I have a formula for that. If I apply the inverse Laplace transform, I will get f of t, the solution, to be. And if I look at which of those matches a minus in the table, s squared minus 1, s squared minus 1 with a number, it's right there. So the one matches. It's the hyperbolic sine of at, the hyperbolic sine of at, 1 because that's a 1. I do want to mention, you might look at the back of the book, and the back of the book will have 1/2 into e to the t minus e to the negative t. And there it is, that's the solution. And what if I have a non-homogeneous equation? I'll apply the Laplace transform. I will get s squared times f of s minus s times 0 minus a 1 minus 2 times s times f of s minus y of 0, which is 0, plus twice f of s. And what is the Laplace of e to the negative t? What's the Laplace of e to the negative t? Isn't that 1 over s plus 1? Isn't that 1 over 1 s plus 1? Right? So, if I really look at this, this says f times s squared minus 2s plus 2 equals 1 over s plus 1, that's a 0, plus 1 if I'm not mistaken. And if I am debating, should I combine those or should I leave them? Yeah, why not? Let me combine them. Wouldn't that be s plus, let me think. Would it matter if I combine them or not combine them? Yeah, why not? So over 1 multiplied by s plus 1, that's 1 plus s plus 1. So that is s plus 2 over s plus 1. And now I'll say f equal s plus 2 over s plus 1 times s squared minus 2s plus 2. Wouldn't make a difference? No, it wouldn't make a difference. You still have to do the same thing regardless. Yeah, I think that's about it. So if I want to know where this came from, I'm going to say that's a over s plus 1 plus bs plus c over s squared minus 2s plus 2. S plus 2 equal a into s squared minus 2s plus 2 plus bs plus c times s plus 1. And if I let s equal 0, no, s equal negative 1, I'll get a 1 to equal a into a negative 1. That will be 1 plus 4, 5 plus 0. So I'll get a to be 1/5. You could use the Book's method or wherever you learned. If I let s equal 0, I will get 2 equal 1/5 times 2 plus a 0 there and a 0 there, c. So I can get c to equal 2 minus 2/5, which is 3/5 positive. And if I look at, let me think really quick, just s equals 0, that's a 2, that is negative, oh, I'm sorry, 10. 10 minus 2 is 8/5. And if I let s equal 1, now I can get the rest. This is 8/5. S equal 1, I will get 3 to equal 1/5. A 1 in there, minus 2 plus 2, that's a 1, plus b plus 8/5 times 2. So I'll get 3 to equal 1/5 plus 2b plus 16/5, and that would mean 2b equal 3 minus 1/5 minus 16/5. That's an awkward looking 5. And what is that? All over 5. That is 15 minus, 15 minus 1 minus 16. What does that make it? That will make it negative 2/5. And if you divide by this 2, b will be negative 1/5, if I'm not mistaken. So basically this is what I got. From here, I got c to be 8/5 and negative 1/5. So I'm looking at f equaling 1/5 over s plus 1 minus 1/5 s over s. Oh boy, let me think how I'm gonna do this. No, I gotta take this a step further. There's a shift. Let me do the shift first. So remember, if there's a shift, I have to match it top and bottom. The denominator, I should have did that. Isn't that s squared minus 2s? Don't you need a plus 1 and a plus 1? So wouldn't f equal 1/5 over s plus 1 plus, isn't that s minus 1 squared plus 1? So for the top, it's really negative 1/5 s plus 8/5. If I take the 1/5 out, if I take the negative 1/5 out, wouldn't that be s minus 8? If I'm not mistaken. And let me see how this works. I could say f equal 1/5 into 1 over s plus 1 minus s. I need that to be a minus 1. So wouldn't that be minus 1 minus 7 over s minus 1 squared plus 1? Can't I say f is 1/5 into 1 over s plus 1 minus s minus 1 over s minus 1 squared plus 1? Now this negative is going to distribute into that. Isn't that 7 over s minus 1 squared plus 1? And now if I say, let's apply the Laplace inverse transform, wouldn't you say f of t, which is the solution to this equation, is 1/5? Isn't that e to the negative t, and that is by e to the negative t by 2 minus e to the t will take care of that shift, making this s over s squared plus 1. S over s squared plus 1 matches s over s squared, matches a cosine, number 6. Matches a cosine of 1t, that is by 6. And that is by 2, the shift. Plus 7 times, and here, isn't that also e to the t? That takes care of the shift, and that makes this a 1 over s squared plus 1. 1 over s squared plus 1, that matches a sign by 5. And what I did, I found the solution to a differential equation. I found both the homogeneous, and so the particular and the complementary part altogether. And there's your homework on this section. A lot to practice with, so make sure you play with that.